All right, howdy, and welcome to my video on planning and coding FRQs. So an FRQ, you get a prompt, you ask you to write a certain program or function or something, and you will have to, um, sorry, okay, and you will have to, write the code for it. So I have a prompt on my screen right now, and this is a prompt from last year's set of practice problems for one exam. And the prompt says to write a program that will ask the user to enter names and ages of people, stopping when an age of 0 is entered, and not processing that person. The program should collect this information and then output the average age, the name of the oldest person, and the name of the youngest person. Assume no two people have the same age. Okay, so before I start, I want to highlight important information in this prompt. If you have scratch paper, maybe write some stuff down. If you're doing a lab and you have the liberty of doing whatever you want on a quiz or an exam, you can't really write on the screen or open IDE. So you might type this out or just write this out on a piece of paper. And I'm looking for a few things. First is input. Second is output. Because ultimately, I need to know three things. What is my input? What is my output? And how do I get from the input to the output? In other words, what is the main process or processes I need to do to convert this input to the output? So I'm going to color code this. So my input, right? It's going to be the names and ages, right? Because of this enter, right? So this is input. This implies input. And I stop when an age of 0 is entered, right? So this stop on a condition, right? This means what? My input will be a while loop that takes in two inputs at a time. One will be the name, and one will be the age. Oh, sorry, I wrote it the wrong way. Input age. Now, what is the condition, right? The condition is when age of 0 is entered. So while loop, while age is greater than 0, right? You could also just do not equal, so that probably will be more precise, right? I don't know why people do a negative number, but if you're strictly interpreting this, right, then your condition will be not equal to 0, right? Because you would stop when it equals to 0. So this is my input. So I'll set this aside. That's how I want. Where is it? Delete this. Make this smaller. And bring me here. And highlight this stuff. All right, sorry about that. So anyways, okay. So now that we have our inputs done, let's move on to the outputs. So the outputs, I will do this in green. Right. Okay. So the outputs. So it literally says the output, right? So everything says after this should be the output. So for the average age, the name of the name of the oldest person, and the name of the youngest person, right? So our output is threefold. I need the average. I need a name of oldest person. I also need a name of the youngest person. Okay. So I know our input, I know our output. Now the main problem is, how do I bridge this together with code to get from input to output correctly, right? So I want to clear this real quick. And I'm going to remind myself of quickly what input is. So my input, right? A while loop. I'll say a while condition. I take in two inputs, name and age. And for my output, I want average age and the names of oldest and youngest. Okay, so for our process, right? The first thing is, how do we get the average, right? So our average will be the sum of all ages divided by number of ages, right? Okay. Now, there's two ways of doing this. The first way is a list. And you can do like sum of the list divided by length of the list. And it's fine and dandy, except there's one problem about this. We also need the names of the oldest and youngest, right? This implies, right, if we use the list, we just sort the list. But if we sort a list, right, when we deal input like this, right, you can realize that if we have a names list, an age list, when we do our input, and I'll just do random as we go, right? When we do our inputs, the corresponding inputs, the corresponding name and ages are in the same indices, right? So the first pair of values we write in, we at this location, then the next, so on, so forth. Actually, let me use proper indexing. So the first person will be at index 0, index 1, index 2, so on and so forth. But the second I sort this list, right, and I write this as, it becomes ages equals, oh wait, this is already in order, right? But what if like we shuffle around, right, and go like 4, 3, 2, 1, just for sake of example, right? Now the names are mixed matched, right? Oh yeah, like D, C, B, A, right? How do you reconnect the names and ages together? This problem can be solved with a dictionary, right? You can write a dictionary where the keys are ages. Why is this valid? This is valid because of this right here, that no two people have the same age. Your keys need to be unique, so you don't avoid overlaps. If I made the name the key, we never said the same, different people can't have the same name, so I might accidentally overlap, an age. I might have two separate people the same age, but one of them is the youngest, one of them is the oldest. And what if I overlap that? I will no longer have both the oldest and the youngest. I just have one of each, just the one that came after, right? So keys are ages because of their uniqueness. This means the values are the names. So when I sort each age, I can just grab the age and find a value. But this is pretty complex, right? You need to know, what did I write here? You need to know, what this average formula is, right? You need to know that, oh, when we make the list, the person's information are in the same index in both lists, right? And if we shuffle the ages list, That means this order, right? The fact that the names correspond to the same index is incorrect. And a way to rectify that is to make a dictionary. You sort the ages and go through the list, right? And you just grab the person's name based on their age. But you need to know lists, you need to remember sum, len, sorting, sorry, not sort of sorted, right? Also dictionaries, making them correctly. There's a bit simpler way of doing all of this. Let me erase some of this. All right. Oh. There's another way of doing this. And the thing is, we can still use the same formula. And as average equals the sum of ages divided by the number of ages. However, the way we calculate these two will be different. A better way to do this is that as we process each person, right, we add, so we have we have an age counter, right, and we have like the number of ages counter, right? So every time we process a person, we add age to total and one to, let's say size. I'm gonna rename this as size so I don't have to write so much. Okay. Size. Okay. So this means that once we go through every single person, right, we have added up everyone's age and we have counted up how many ages we've gone through. So this is great, right? We have the total, we have the size. That means we can calculate the average. And the problem is, what about these two, right? If we're not storing the names and ages anywhere, and we're just adding up two counters, the total age and the size, or the number of ages, how do we determine the oldest and youngest person? Now, this follows a similar pattern. Instead of having to make a list and sorting that list and then identifying which name goes with which age, we can dynamically update the oldest and youngest person as we go. What I mean is the following. So let's say I start with a random youngest. Actually, I'll give an analogy for this. Let's say I went through a list of numbers. 1, 3, 7, 2, -1, 0, right? And I wanted the smallest and largest, right? So what I'm going to do is I'm going to look at the first one and mentally keep this as both my smallest and my largest number, right? Now I go to next number, 3, right? We can now update the largest to 3, right? Now we go check 7. We compare the 7 to 1 and 3. It's not smaller than 1, but it's larger than 3. So we update that. We go again down to 2. Now 2 is not smaller than 1 or larger than 7, so we continue on to the next number, -1. -1 is smaller than 1, so we update that. But it's not larger than 7, so we leave that alone. Now we go to 0. 0 is not smaller than -1, but it's not larger than 7. So you can see, again, as we process each input at each iteration, all we have to do is compare the current age to the oldest and youngest age, which is the largest and smallest age, respectively. Now, note that they don't want the age, they want the names, right? So in this case, we can do two things. Instead of just storing the smallest and largest, right? We also put names for each of these. Oops, sorry, no. And as we go through each value, right? You go for this value and this value and so on and so forth. We can also update these values based on the age associated with them. So from that, I now know how to do my input. I have my input, my process, and the output. Okay. So now I can start, so my input, right? This first option, I'm gonna do a different color. For my input, while loop, right? We're gonna do some age, right? Not equal to 0, and we grab the inputs. Name and age. Remember, for this while to work, you need to actually ask them at the start, right? So you ask them to start for name and age, and then while the age is not 0, you right, while that. Okay. Now you get to a process, right? We want to let me choose a different color. No different color. Okay. But now it's not a different color. Okay. Now we're gonna do, we want to update total and size, and this is for our average, right? Then we're going to update the youngest person and update the oldest person. So I'm going to check my notes real quick about this. Okay, so now I have my process, right? This is how I will determine my outputs. And once I have that and I have my outputs, I would just simply output the average and then the names, right? But now from here, I need to consider any edge cases. In particular, anything that breaks the code, right? So particularly one is, what if I start with an age of 0, right? If I start an age of 0, this while loop doesn't run. And that means my size is 0, which leads to average equals 0 by 0, right? This is my total. And this is my size, right? This right here, it's an error, right? This is a 0 division error. Or division by 0 error, right? So how do I negate this, right? So with this one, what I want to do, well, that's not even reason. What I want to do is before I output, right, I want to check. I want to check size and update the average, right? Update average. There's two scenarios. One is if size is 0, we set some default value I choose. Otherwise, we do standard total device size calculation, right? So this covers my first edge case. And actually, this is my only edge case. There's also the problem of multiple same names, right? But the thing is, this is irrelevant. This is irrelevant. Because my check, right, is based on this checks based on age. And ages are all unique because of this sentence right here. Right? No two people have the same age. So if I'm comparing based on uniqueness, right, a unique property, that means I won't have a problem overlapping people, right? And if I check by name, then that's another problem. But having multiple people with the same name won't affect anything, right? They can be the same name, but differentiated not by their name, but by their age. So this is something I don't have to worry about. And now we have other things to worry about. Now, what if I'm running out of space? So I'm going to erase this left part. So what if I have invalid input entirely? Like I have weird numbers or just bad input, right? So my third, right, is bad input. We can have strings, right? Maybe we have floats. We can have, I mean, your regular integers, right? So we want this, right? Because ages realistically are integers, right? Specifically positive, right? So at this point, right, this is assume based on prompt. If the prompt says that you can assume there's no bad input, then you don't have to worry about bad input. Now, if you don't say anything about bad input, right, you should probably check with your PT or professor to ensure that you're allowed to assume realistic ages, right? But even if bad input was allowed, right here before, sorry, not right there. Right. Somewhere like right here, right? And right here, right? So right before the while loop, right after while loop, or before and after, right? You want to probably try catch, right? By trying to cast it the age to end, right? For this video, I'm going to assume that my assumption is that we only get nice numbers. They all will be non-negative. I'll say non-negative because the condition to end is 0. If it's strictly positive, then I actually will never process 0, which is a little unfortunate. So for sake of this video, I will be coding as if I will get only non-negative integers. But do realize that, when we do, when you are taught how to do try catch, exception handling, all that good stuff, right? You may have to really consider bad inputs and properly catching those inputs and letting the user know that they've done something incorrect and let them try again. But this is a module 5 video I'm trying to do, so I won't be that in depth, right? So far, this is like my pseudocode. I will do a lot of backspacing really quickly. Give me a minute. All right. Select this. Okay. So far, my pseudocode looks like this, right? And it's quite a lot. I mean, it's not too much, but it's a decent bit, right? We have our inputs, right? We have the process, which I already written over here. We have, this is an edge case tester. This is your output. And this is also part of your input, right? So far, I've spent the first, I don't know how long I'm recording, but the first few minutes or so just planning and analyzing this prompt, right? And now that I have this plan, I can go ahead and set up my comments. Yes, I said I'm going to set up my comments. This is because I'm going to do this right here. Good. So when I set up my comments, one, this gives me partial credit. Remember that you will get partial credit if your comments do reflect an accurate, it's like specific and accurate to a step that is necessary, right? Maybe you write the code slightly wrong, but if you write a comment, you might get partial for it. So take off my drawing glove. So my first comment is what? Grab the inputs. My next comment will be the loop, right? Loop plus update values, right? Maybe I do another comment and I do set variables for average, youngest, and oldest, right? You see my comments aren't very long. They're just very straightforward. If you want to be more clear, right, go ahead, but do not waste too much time on this, right? If you have time at the end, maybe make your comments a little more readable, but that is if time allows. So far, right, these three are my inputs. Actually, I'll annotate that real quick. So far, actually, I won't write quite yet. And continue typing. So I know around right here, right? This is my while loop. Actually, I'll start drawing. So this right here, right? Like this step right here, it's this one. For a process, right? This is for my process. So I should have written it in my pseudocode, right? But this is my first step for a process, right? Is to track these values right here, right? And now when I make the loop, this part, right? Right here is the loop, right? And then I remind myself to update the values, right? Which is this whole part right here, oh, and right here, right? So that's the second part of the process, right? But in here, right, I do want to know exactly what I'm doing, right? So somewhere over here, I want to write, update average, right? And to update the youngest, update oldest, right? And this is just straight from here, right? And then I want to retake input. I'm just writing this out, so just for emphasis, but yeah. So take this out real quick. Okay, so I missed these two. So continue typing now. And what I'm going to do is add a comment, and this will be update total and size, right? I'm going to update youngest name and youngest age, update oldest name and oldest age. Okay. And here is retake input. So you can see that each of my comments here directly leads somewhere. So this one is this comment, right? And then this one goes right here. This one goes right here. This one goes right here. You can see that with somewhat proper plain English, right? I can make comments as well that reflects my pseudocode. Okay, so with that out of the way, right? Now we're outside the while loop, right? We can now check and update the average. So this is my edge case, and then view my outputs. So again, I will show that another part of my pseudocode is right here, and the last part of my pseudocode is right here. Why is this important? All the steps I've written down are important for me to actually write out this code. If I miss one of these steps, I might do it wrong. In fact, I just realized as I'm writing this, I actually forgot to elaborate on something. And that is how exactly do I update youngest and oldest, but I'll talk about it in a second. But you can see here, right? I can take all this stuff over here, right? And translate it into these comments. And this is good in general to help you make good comments as well. So when you read your code, or maybe on your FRQs, right? You write your code, and you go check your answers, you come back. Maybe your brain is fried, right? But if you read your comments and it's pretty detailed, right? That means you can read your code and you can probably understand pretty quickly. It also means on the grading side, right? It's easier for me or whoever your PT is to look at your code, read the comments, and then if it's clear or pretty clear, right? If they're pretty clear, we can also guess how your code should look like, and it makes our lives easier. And especially when we're trying to give you a partial credit, right? If we want to give you partial credit, and if you have the comments there, that's probably a good decent chunk. And obviously, if your comments are clear and we see that, oh, you just made a very small mistake here, it's not that you entirely ruined your code. It's just the way you thought might be a little weird. So the implementation is weird as well. And you have a small mistake. There we go. We can just take off minimal points instead of a lot of points if we accidentally don't fully understand your thought process. All right. So we are done with the pseudocode. Sorry, we're done with the analysis, we're done with the pseudocode, we're done with commenting, which is like the framework of our code. Now, all we have to do is build the code. So grabbing the inputs. So we need to first check is the name, right? And the input, I would say enter the name or enter a name. My age can be int input enter an age. So let me check my notes again. Right. Now we set the variables to average, or the average, the youngest person, the oldest person. So my average requires what? It needs a total and it needs a size. The reason I don't use sum, right? So right here, right? I did not name as sum. Oh, there's the hint right, because sum is a built-in function. So this is built-in. It's awkward when you use a built-in function name as a variable name. It might have unexpected consequences, it might not. But on an FRQ where you can't test your code, you don't want to run that risk, right? So do try to avoid variable names that match a built-in or a keyword, especially with keywords. That will definitely be very bad, right? Now for youngest person, right? So we have youngest name, and I'll set the empty string. Youngest age. We'll put it as 0. I'll talk about that in a second. Oldest name, blah blah. Oldest age, 0. Okay. Now the question becomes. So, and this will happen when you code sometimes too. With this, right? The question becomes, what is my default value? Right? Python doesn't really have a max integer. If I remember correctly, it's just based on your memory. So that means you can write some like ridiculously long number, and it could still be beat by a number in size. So, and to my knowledge, I can't remember off the top of my head of how to access your biggest possible int, but it's not really taught. That's not taught. So how do I safely set the oldest and youngest person, right? The safest way to do this is like with my example earlier, when we were counting the numbers, right? Is what do? I set my first number to be the smallest and the largest. So in a similar fashion, right? My youngest person, right, should default to the first person I process. Similarly, my oldest person should also be the first person I process. Because at this point, right, when I'm doing like person after person after person, right? 1, 2, etc. When I've only processed one person, they technically are the youngest and the oldest at the same time, right? Because there's no one else to challenge them. There's no one younger than them, and there's no one older than them. So by definition, they are the smallest and the youngest. So if I set these two, these four variables to match the first person, I should be okay with future comparisons. But now here comes the other problem. How do I know which person I want? I could use a counter. Here's the thing. I actually only care about not which person, but how do I know if I've processed anyone? So this becomes a lot easier to answer. And instead of this, we use a flag, right? This defaults to false, saying that I have not processed anyone. The second I go and process the first person, right? And I set the values, right? And I set the values. I change this to true. That means I have processed someone already. And that means I do not need to set all four to the next person, right? So I don't have this flag. I'm just going to set the next person to be smallest and oldest, so on and so forth. It's going to get really, really awkward. I need this flag there in order to, I need the flag in order to correctly set the youngest oldest person to just the first person. So has processed person. And right. So I'm done with my inputs for now, right? And I'll re-annotate. You see that I have my starter input, right? I have my variables, information storage, right? And I have this flag to help with the process of setting the variables. But now I need to do the while loop. This whole part here is my while loop. So let's go from that real quick. Okay. So while, and what's my condition, right? My condition is I need to stop when age is 0. The opposite of that is I run while the age is not 0. So while age is not 0. Right. Now I update the total size, right? So total plus equals age, right? Size plus equals 1. Where size is a counter. How many ages do I have? The total is the sum of the ages. So I want to add the actual age value itself every single time. Update the youngest name and youngest age. Now, remember what I said before, right? One is I need to update for the first person, right? Second thing I need to realize is if I actually have someone younger or older, right? So with this in mind, right? Let's start with a condition. So first is, have I processed anyone yet, right? So if I have not, right? I want, like, remember, these conditions only run if the condition, the Boolean expression is true, right? So not false, I need the opposite of false. So not has processed person, right? Or, right? So one of these two. Or age is less than youngest age, right? So these are my two conditions, right? This is my second condition. So actual youngest person. And this is, oh, I need to update for the first person. And with the same line of thought, this will also be the same if statement than the other one, except Since we're doing the oldest person, we check for greater, right? Remember that we said that they're all unique ages, right? So I don't need to worry about, I do not need to worry about duplicate ages. Everyone has a different age. They will be a strictly youngest person and a strictly oldest person. So that's good. That simplifies my code quite a bit. And again, just reflects this right here is my first condition. This right here is my second condition, right? This one, then yeah, this one. So my if statements are formed correctly so far. Now what I do is update, right? So my youngest age become the age, right? And my youngest, the person's name will be updated to the name I have, right? For the old, I just do the other pair instead. Oldest name equals name, right? Now the other question is actually, this is always a question you need to ask when you do conditionals. Are these two dependent on each other, right? Because if it's yes, we do if elif, right? If it's no, we do if. The answer is no, right? And you might be asking, what if I did elif right here, right? Remember that on the first person we process, right? On the first person, we need to update both the youngest and the oldest. So I did elif here, right? And it's the first person, right? This is true, right? So this whole thing also becomes true. So you run this code, right? But if this is an elif, right? If this is an elif, this only runs if this was false. Right? Obviously it's true. That means this doesn't run. That means what? My oldest person is not updated properly. You do not want to do if and elif if there's no dependency on each other. Or in other words, the second condition doesn't depend on the first condition, right? You can do check for both and they won't influence each other accidentally. Yeah. Anyways, now we have our if statements are done. We're going to retake our input. So name equals input, enter name. And my age, again, assuming good input, I'm going to cast it in, enter number, enter an age. All right. And this is our while loop. This right here is your average, right? This right here is for youngest person. Sorry, this right here is for oldest person, right? And this is the majority of my process, right? I still had some up here, right? And some about right here. But in this while loop, this is all the process you can do, right? And right here is very key. I need to keep taking input. And again, this matches comments, right? Making sure code matches your comments will help you quite a lot. Now we move on to checking the average, right? Remember that I said there's two important things to consider. The first is size equals 0, right? So I want the average, let's do it NA, right? There's no specification output, so you just need a common sense check. You need to output some value that obviously tells that there's an average. So I'll do NA. But now remember, my outputs are three things, right? And I should probably add this to the comment. So the average age, name of youngest, name of oldest, right? if my size is 0, this also implies no youngest and no oldest, right? So not only the average NA, I need to set my youngest name to NA, like the string, and my oldest name to n/a, right? But this is my main thing, it's size 0, right? Otherwise, if size is greater than 0, right? Youngest and oldest stay the same, right? You just keep the original names. And then you do average equals total divided by size. And this is your definition of average. So this in mind, let's go code it. Oh, I never did it. In here, right, you can also do, case 1, size is 0. Right? And do if size is 0, right? I said average equals actually we can do this, right? We can assume the inputs are good. And the inputs are good, what stays the same, right? Actually I can't do that. Case sorry, I'm lecturing too much. Case 1, I'll just write it out, sorry. If size is 0, right? This is my first case. My average becomes n/a, right? My youngest name becomes n/a. My oldest name also becomes n/a. Note that I don't need to change age. Why? My output is just the names. I don't care about the ages, right? Else, right? My average will become all divided by size, right? Note that you can simplify this code a bit, right? Sorry, I look my notes. My default values, my default values for youngest, my default values, right? These are obviously like bad values, right? So if I output it like youngest and oldest, right? And I saw nothing, right? I'd be confused. But if my average is NA, right? And I don't have anything here, it makes sense, right? If I don't have an average, I also don't have statistics on the youngest and oldest. So a variation of this is you could have written this, right? Your youngest and oldest, you don't need to change your values really, right? You just keep them real plain. I mean, it makes you happier. You just do this as well, right? And set these default values. So they make no sense when output originally, right? This right here can also be simplified. And this is just if you care, right? You can assume I'll just separate. You can assume the average is bad, right? And if it's actually valid, you can update it. So this variation, right? What I'm doing is I assume bad input as size is 0. This is not like bad input, it's just the edge case, right? And then I update if valid. This is fine, right? If I have size as 0, this doesn't run, and I would not run into my error. If I do have a size, that means I do have legitimate people, I update the value at the very end. This is the last update to average I would do. So my average will also be correct. But for the sake of clarity, I'm just gonna I will just, sorry, let me do this. For sake of clarity, I'm gonna go back to my original version. Because, this does require a bit like thinking for efficiency, and that might not be something you have the time luxury to do, right? This will get you, it's the most straightforward way, right? Size is 0, so everything to NA, else you calculate your size and keep your variables the way they are. Now the outputs, right? The output's pretty straightforward. I'm gonna use upstream because why not? There's no depiction of, there's no specification of what the outputs should be. So I am at liberty for this. So the average age is, and I'll just say average. Do not format, right? Because if I did this, right? This assumes a number, right? What if you had n/a put here, right? This is an error to format a string like a float in this case, right? So I do not want to format anything. I mean, again, didn't specify anything, right? So I actually don't need to care about rounding. And I'll just leave average as is. I've been printing out the youngest person. The youngest person's name is this person. The youngest name, right? I can do the same for the oldest. All right. And there we go. We have our edge case test, right? This is our edge case code, right? This is our typical case, we can say, right? And then we have our output. So all in all, right, every single block of code I've written has a specific purpose to them, and they're part of input, output, process, or a test case, a typical edge case scenarios, all right? Now my code is done, right? And I would probably submit this as is. One, because I already know this code is more than likely correct because I'm looking at my notes right now. And two, right? When you're in exam, right? You can't really afford a double guess yourself, right? If you have the pseudocode written out, you have the comments written out like this, you can give it a glance, right? Give it a nice, good look. Make sure that you didn't use your wrong variables or something like that, right? Remember that you won't be penalized for syntax errors that don't, destroy your logic entirely. Like a missing colon might not kill you. But like if you miss this entire operator, that's probably gonna be points off. But a missing parentheses or extra quote, and that's not going to kill your grade. What we want to see, right, is do you have all the pieces, right? The inputs, the outputs, process, right? Each piece of the process. And then certain questions will tend to lead towards a certain structure, right? Like this prompt stating this implies you probably want a while loop because you're doing something over and over again, asking for input until a condition happens. You can't use the for loop because your condition is based on a variable value comparison, not when you reach a certain number. Right. And then this edge case right here, right? This also tests, can you think about what could happen with valid, can you identify typical and edge cases, right? There's not really a corner case, right? I guess you could say size equals 0 is a corner case, right? It's an edge and a corner in my opinion, but it is, there's only one way to get it, and it's if your first age is 0. So it could be a corner case as well, right? But everything else is a typical, right? Just your standard name and age. Okay. So, but for the sake of this video, I will go through some test cases. Okay. So let's say this is a lab, right? And you want to make sure this works for real. Why don't you just run through your Zybooks and see what it says, right? Grab the test cases, let's see the test cases, and then use those, which is smart. I would spam Zybooks per se, but if you're curious about if you're missing something or not, or like I said, right, my assumption was that my input is good, but maybe the test cases has some not so good inputs. You can then change your code in order um, to reflect the test case. I'm gonna write it down. So for labs, right? For labs, you can run in Zybooks once, right? To see test cases and test code locally with those tests, right? That's pretty smart. Run in blah blah blah, right? Now let's say you're on like an FRQ quiz, right? You can't really run into Zybooks. You don't have anything to submit to. You need to just derive cases yourself, right? In this case, we have to do option 2 because we don't have a Zybooks for this. So let's think about things that could throw my code off. And it's not actually much. One is I start input like Tony0, right? This is my name. This is my age, right? So this is my edge case, right? My second one is I have just one person. So we have name again, age again, and followed by name, age, right? So Sophie here won't get processed, only I get processed, right? But remember, in my code, what should happen? If my flag is done correctly, and I just realized I forgot one thing. In my pseudocode, I completely forgot this. I need to set flag to true. And see, with the test cases, I even caught myself doing a mistake. Has processed me think it's true, right? My person, right, myself should be the oldest and the youngest, right? Actually, let me space this a bit. Oh, that's how I want. So I drag it. There we go. Let me also write the expected outputs, right? So the outputs, right? Shit, NA, NA, NA. And this is your average, right? And your youngest, your oldest. So that is your first test case, right? And then down here, right? My output, right, should be 1.0, right? Because when I did my average, right, it's a float. Don't do integer, right? Because if you have the sum of 5, you have 2 ages, right? This should be 2.5 and not 2. So use regular division. So my youngest is me, who is also the oldest, also me, because I'm the only person. Now, my next test case is what? Let's do a normal test case, right? So I want to make sure that I get updated, right? Let's say someone else gets their value. Let's do 2, right? And then we put someone else, yeah, like this, right? Actually, yeah, I'm going to switch up the numbers a bit. I want to make sure that the other if statement checks properly. Oh, that's a clear button. Replace that. That's a lot of erasing. So 2, 1, right? And then we'll do, I don't know, like 0, right? Now our output should be what? This should be 2.0, right? 2136, right? And then Sophie should be the youngest. Ryan should be the oldest. At the same time, right? For this one, Luke should never come up as the youngest. Same with this one. Sophie should never be the youngest, even though she does have the post age. With this in mind, let's go test our code. Pause this. This would be really awkward if I was wrong. It's okay. So first I do Tony, next I do 0. And this does check off my first, we can do this. Oh, check mark. It's a really small check mark. I don't like that. So I'm going to change my color to green. So yeah, right. We have NA, NA, NA. So that's what we're going different. Now let's do our next test case. And you can do this by hand, by the way. You can manually go through your code and trace the code as you go and do it. It can be pretty annoying. So if you do hand annotate, I would suggest that you have enough time to do so. Or as just write out the test cases, just kind of mentally think, does your code work or not? If you're low on time. Run it again. Let's do the next one. It's Tony 1. So good. I do still collect input 0. Good. My output is 1.0 Tony. Excellent. This means what? I correctly do the average, right? And then my update for the first and second person using the flag is correct. Great. Now, oh, that's all I want to do. My final thing to do is the last test case, right? Last test case is very holistic. This is for free, right? We're shuffled numbers, right? You have a new youngest person, a new oldest person. Yeah, so we're not in order, and then you update using the if statements, using the comparisons. That one is like one more down here. It's like age greater than oldest age, right? So this will check off both the second part of my if statements, right? It will check if I used or here correctly, right? If I wrote like and, right, this will not work because this is not true, which evaluates to false, and false and anything is false, which means thing will not update correctly. So the rest of the code I haven't checked, which is, did I use the correct keyword or, and did I correctly do the second comparison correctly? That all gets tested by its last test case. So it might not seem like much, but it is a very nice test case to test everything else I'm missing. That's quite the eraser. Boom. There you go. Okay. So let's go rerun our code. Where is the run? Here it is. Okay. So first, I'll type in Tony 2, and Sophie 1, Ryan 3, and then be Luke 0. Not yet. My desired outputs, right? My average is indeed, oh wait, I'll pen backwards. My average is indeed 2.0, right? The youngest person should be Sophie, and that's what I get. My oldest person should be Ryan, that's also what I get. Based on these test cases, I have the confidence that my code is correct, right? Obviously, right, you still can make mistakes, even with what you think is correct pseudocode, as you saw me mess up and forgetting this very important line of code to set the flag to true. Otherwise, I would update every single person to be the new youngest and oldest. Right? And then I think midway, when I was thinking about test cases, right, I updated my pseudocode to acknowledge the edge case of the size being 0, right? And obviously this is also me acknowledging a typical test case, So all in one prompt, right? We're testing your usage of input. We're testing, can you convert your input to the correct data type? Can you use different types of variables? You have int, strings, booleans. Well, for my type of code, a boolean, right? Definitely can use a while loop because this prompt really highlights. I'm going to clear in terms. This really emphasizes on the while loop, right? This phrase right here. Can you do the logic correctly, which means did you plain analyze the prompt correctly, right? Obviously, the actual part is retaking input, right? Are your calculations done correctly? Did you test? Did you think about different edge cases and did you acknowledge them? And of course, does your output match? So at this point, my testing's done, my pseudocode's done, my code's done. I can safely submit this as my FRQ or quiz or whatever, right? Obviously for labs, if you still get errors, right, then you need to go back into the code and find out what's wrong, right? You could do a debugger, right? And if you see something that's happening when it shouldn't, you can just set a breakpoint somewhere and step through the code as you go. All right. Just for an example of how the debugger works, right? I want to set my breakpoint right here. Actually, I want to set it like right here, right? And I want to check. I want to see if this whole thing gets updated correctly, right? So I'm gonna hit run in debug, and I did always a Python file, right? So if it runs, right? So right now it's waiting for me to do input, right? So let's do my initial test case, right? We'll do Tony, right? And we'll do actually I'm gonna do a regular test case. So Tony one do okay. So we're in this while loop now, right? You can see all my values in here. You can see the name, right? Oldest age. So this is posting correctly, right? And then the age somewhere here. You can find it. Yeah, age is right here, right? I don't know how to make this any smaller. Oh, there you go. Yeah. So, oops, sorry. Okay. My input saying correctly, right? And you see that there's no quotes, right? The quotes are missing. So this is actually a number, so that's correct, right? My name's also done correctly. And my default values are good. This is also good. So far, so good, right? Now it's going to check this conditional. So we step in and see what happens. Step in is to execute line of code, or like do the next thing. We step, and you can see that my age is 1. It's not 0. So it's going to update total. And you can see right there, it flashed in green, right? And you can see that the highlighted thing, right? Means it changed. It went from 0 to 1, which is 0 plus age. So this is correct, right? And we continue on each step, right? A size update, same thing, right? It's 0 plus 1. You continue, right? And now you can see that it has gotten here, right? And it's actually kind of hard to evaluate which of these went in, right? Which is why you need to debug with a large test, sufficient test cases, right? Step in, step in. And you can see my youngest ages, right? I'll step a few more times, right? You can see right here, right? My first person, right? My first person is updated both the oldest person and the youngest. And this is good for my edge case of only one person. We continue on, right? We set the fact true. And right here, right? The fact's not true. This is now evaluated to false. This is also the false. So the only way this if statement works is if this condition is true. Because it only cares about 1 or 2 being true. And if this is always false, that means this must be true for this OR to value true. So we step in, ask for name. I'm gonna do Sophie, and then right now to ask for the next age, right? I'll say 2. Now we're back in the while loop. We step update, right? And I see it's whole into 3. So 1 plus 2 is 3. That's good. The size under 2. So that means I added 1 and on the age by accident. This is good. Now at this point, right, you know that the age is 2, right? You see right here, the age is 2, and the youngest is 1. 2 less than 1 is not true, right? So I should skip this. Excellent skips, right? And at this point, you see age versus oldest age, right? Is 2 greater than 1? The answer is yes. I should go through to this if statement. Yeah. And you can see at this point that my oldest person is now Sophie. So this is so far so good, right? Now let's continue on. I realize I should have been 3. It's okay. Now let's see if sorry, I can't do oldest person, huh? That's okay. We can. Hey, that's fine. We'll deal with it. So ask me another thing. Well, let's stop it early. Do Ryan, and then it's going to ask me for an age. Hit 0, right? Now it's while loop, right? Does it stop correctly? And it does. It skipped everything to while loop, right? And now we're down here. Is size equal to 0? It's 2. This should be false, right? It skips. Excellent. We calculate the average, and now we have this average, right? Now we just do the print, and our program's done. It's also really good for testing edge cases and stuff. I kind of messed up my test cases there, but you can see that when you step line by line, right? And this is like for labs, right? Or homeworks, right? You can't reduce on a quiz or an FRQ on exam. For labs and homeworks, when you have the luxury of a debugger and just paper and time, you really should take your time to really read the prompt, play it correctly, make your framework with the comments, and plug in the code, make your test cases. Well, think about the different typical edge corner cases, make sure your code addresses them all, and then run them through some tests. And if you want to be super sure, you can run through debugger, or you have any problems, also run through debugger and see where something went wrong. And this is it for my planning and coding video.